Welcome to Lunch with Tech Leaders, where we have engaging conversations about software development and cloud engineering with industry leaders and subject matter experts. These episodes are created by the Great Lakes Tech Leaders, an online community of technology practitioners. Please come join the conversation by visiting gltl.rbn.ai. Again, that's gltl.rbn.ai. Now strap in, because we're deploying to production in 3, 2, 1.
All right, welcome to the latest episode of Lunch with Tech Leaders. My name is Jason Brown. I'm a cloud solutions architect with Right Brain Networks, and I'm your host for today. Also joining us today as our subject matter expert is Preston Frazier, senior software engineer from the Interoperability Institute. Let's see. Also joining us today is business technology consultant Joe Coleman.
Thanks for that intro, Jason. Just throwing it out there. Any listeners, if you guys have any questions at all, just throw it right there in the chat, and I'll be sure to make sure that we toss that in here to be addressed throughout the conversation. So thank you so much.
All right, wonderful. Thank you, Joe. So in this episode, our topic today is AWS Lambda versus AWS Fargate. So both of these are considered serverless compute technologies. And yeah, we'd like to go through and have a discussion comparing and contrasting the two. Before we just roll right into it, I'd like to do just a really brief overview of what is Lambda and what is Fargate, and then we can just talk about the various use cases that would be suitable for either one. So starting off, what is Lambda? So Lambda is a serverless computing service provided by Amazon. Devs can write and run code in response to events without having to manage the underlying infrastructure. So when a dev creates a Lambda function, they can specify what triggers it. So like a file being uploaded to an S3 bucket or an API gateway request being received. And when the trigger occurs, the Lambda automatically runs the code in the Lambda function, which can perform tasks from ETL jobs to application business logic. Fargate is a compute engine that's integrated with AWS's Elastic Container Service, ECS, which is the native container orchestration service provided by AWS. So with Fargate, developers can run containers without having to manage the underlying infrastructure. So what they'll do is a developer can create a task definition that specifies the container Docker image to use, the resources needed to run the container, and any networking requirements. And then when they specify the launch type as Fargate, Fargate will automatically provision and manage the underlying infrastructure to run the containers and including scaling the Docker hosts up and down as needed. So with that, Preston, what kind of use cases would you consider to be ideal for Lambda?
Yeah, sure, Jason. And again, thanks for having me on. Really appreciate it. This is a great topic to talk about because, well, where I work, we always have this decision to make. You know, do we use Lambda? Do we use Fargate? I think this comes up a lot because these are two really big compute engines that AWS has. You know, how I look at it is that Lambda, I always is kind of my start at. And then I figure out if I need to use Fargate later. Just because I like Lambda, it's easy to get started with. It's easy to get set up and going. There's a lot less to configure than Fargate. So first of all, I always start there when I'm doing a new project and determine if I need to move to Fargate. And so I think Lambda really lends itself to architectures where you have jobs and workloads really broken down into small pieces. You know, one of the limits right now with Lambda is that the runtimes can only run for 15 minutes, the invocations, before there's a hard limit that stops those invocations. So right there, you're limited with 15 minutes of runtime. And so I think anytime you can break your workloads down into small digestible chunks is good. And I don't necessarily recommend, going that full 15 minutes in the Lambda containers. That's quite a lot for them to run on. But anytime you can have small workloads, I start there.
Right. Yeah, absolutely. I totally agree with that as well. Another strength that I find for Lambda is situations in which it requires a high degree of parallelization or concurrency. I think that Lambda is really, really good at being able to expand outward very, very well, just due to the nature of how it works.
Agree. And you talked about Fargate being able to scale up as well, and I think we'll talk about that in a second. But you're right. Lambda, I think, has a higher capacity to scale out horizontally, scale out more of these Lambda containers running at the same time. Where I work, we do a lot of we process a lot of health information, and we have a lot of messages that come through our system. And to be able to process those at the same time, we need Lambda to scale out, to thousands of containers running at the same time to be able to process the information. So, and like you said, it can be fed from different AWS services that are integrated, like API Gateway or SQS, Simple Queue Service, or SNS. Being able to feed the Lambda and all behind the scenes, Lambda will scale out, or AWS will scale out Lambdas and start them up as needed. So it really helps itself to consume those workloads.
Right, absolutely. Yeah, and you did mention Fargate as well. So let's shift a little bit to Fargate in the same vein. What kind of use cases would be really ideal for Fargate? Like, what kind of a task would you consider, like if you had to look at it and say, oh, this would be perfect for Fargate as opposed to Lambda, like what would those be?
Yeah. Kind of going back to some of our business that we do, not only do we get a lot of small health information messages, but we get a lot of large, maybe not as many, but we do get large messages, and messages, I mean files. So these could be anything, flat files in different formats, CSVs, that we need to, process all the rows in a file or something. That's a very common workflow. There's a lot of health information messages that people have made custom standards. There are global standards for those. But a lot of times people send to us a lot of data on rows in a file. And, we can use Lambda to break those apart, but it's not necessarily the ideal place to start. With a Fargate task running, we have all the time in the world to really do the work that we want to do. So I see that more as using that for longer running tasks, things where you're going to constantly be using the compute engine the entire time to do the processing. To back up a little bit too, Fargate is something where you can start up a service or a task to run and then stop once your work is completed, or you can run this task indefinitely. So you can have a service started that's always available. And for some architectures that can be very valuable. So I see Fargate is doing two different kind of workflows. You have one where you start up the task and then it stops once the work is done, or two, you have a continually running service. Think about like having an API set up, and this Fargate task is the back end, and it's always running, it's always available to handle these requests that are coming in. And I think that second one's really valuable when you have a high volume service where, API requests are coming in constantly. One thing, and I think we'll get to this later too, but it's a good spot to say it. I think the one thing you don't want to do with Fargate is have a Fargate service or task running and you're not doing anything with the service. It's just sitting there um, spending money.
Yeah.
And I'm sure we'll get to that too, on the cost factors of both of these. But to go back to those jobs that Fargate does well, it can be a number of things, but I really think those long running processes where you're constantly doing work, that's really good for that.
Yeah, absolutely. Those long running, the persistent workloads, the batch processes. Yeah, we touched on it a little bit before moving on to pricing, though. You mentioned using it as like an API, and I know that earlier you had said you typically kind of lean toward Lambda first, and then sort of move into Fargate if it seems like the use case would be more ideal for Fargate. I would like to kind of dig into the API as like a backing web service, for example. Like what would be the tipping point where you're like, okay, well, let's see if we can use this as in Lambda first, but then what would change your mind to move it into something like Fargate?
Sure. So, starting with Lambda, I think that's great for a backend for like a website that is going to receive a lot of API requests doing these small transactions. Maybe they're storing things in the database, or they're calling subsequent web services. You know, uh, when a Lambda is backed behind, say, another AWS service like API Gateway, which is probably a preferred choice to use for receiving requests from a UI front end. Um, you know, API Gateway, just for reference, you can have a RESTful HTTP request open for 30 seconds on an API Gateway. And if you can do your work in the Lambda in 30 seconds, that's a great choice to go with. Another thing to think about is that Lambdas, if they have something called a cold start. So it does take a little bit of time for the Lambda runtime to start. That's usually anywhere. It's usually under half. Actually, I should say it depends on your runtime that you're using. So if you're running Python, Node.js, Java, it's very dependent on that. In addition to any kind of initialization work that's going on before your function actually is invoked. We do a lot of work with Python, and for those runtimes, we usually see cold starts anywhere from 100 milliseconds to 400 milliseconds. And so that's a consideration to take in. Do you need a very fast response time? Initially. Cold start meaning that's the first time the Lambda container starts up. These Lambda containers will run or be available for a long period of time. So once they start up, they're considered hot, and those Lambda containers can be reused. I talked previously about Lambda invocation can last for 15 minutes. That's how long one invocation or run of the Lambda can go for. But the actual container itself can be alive for a lot longer than that. It can be an hour even. So once you get past that cold start and you have a hot Lambda, or if your web service is being used frequently, you'll have many hot Lambdas. And once they're hot, the requests, you don't have that cold start time anymore. So the requests will run quickly. So if your use case is, you don't really need to worry about that, up to 500 millisecond cold start, then that's a great choice to go with. And so I think, on the flip side, if you really can't bear that cold start, maybe Fargate is a better choice for that. And maybe, again, use case specific, but maybe Fargate is a better choice if you have a really, highly available service you really need.
Yeah, I would definitely agree with that for sure. Yeah, because we've had I've experienced issues before with cold starts taking a little bit too long for Lambdas that are used more infrequently, whereas having a constant running um, uh, container to be able to handle those requests can do that more gracefully with that quick response time.
Hmm.
So yeah.
To be honest, I mean, most of the use cases we have don't need that quick response time. So we do have a lot of Lambdas that back an API gateway, um, which is really really nice to use. I will say there are a few tools that Lambda provides to kind of get over that hurdle of cold start. One of the things is called provision concurrency. And this is where you can specify, for an additional cost, of course, you can specify how many hot lambdas you want to always have on hand. So you can, get away from that cold start and always have some hot provisioned lambdas available. Uh,
Right. Sorry, go ahead.
I was going to say that's one tool. Another tool which they just released, I think, in November is something called Snap Start, which is basically uh, um, how Lambda works is you have your code uploaded to AWS, and it's essentially packaged. And when Lambda needs to start up, it'll pull that package and run it. But this released something called Snap Start, and I haven't tried it yet, but it's supposed to basically have your Lambda cached to the point after the cold start so that it is essentially ready to invoke. It's going to be a little bit slower than the provisioned start because the provisioned Lambda is already hot. But the snap start is supposed to be a cached version of the Lambda ready to go. So AWS is certainly making it more enticing and to use the Lambdas to back APIs, I think, than using Fargate.
Yeah, absolutely. And I'm really glad you brought that up because, like, especially with the provisioned concurrency, that's an option that I don't see used enough elsewhere, and that can really help. I mean, there are runtimes, um, uh, like Java, right? It can be really
Yeah.
slow compared to the other runtimes. And having like these new tools that they're releasing to help mitigate that issue would definitely help to drive more people towards Lambda.
Yeah, I certainly have seen that. We had some old applications that were using Java with a Spring Boot framework, and it would almost take 7 seconds for a cold start that to run. And I think maybe I was a little more naive at the time, thinking, oh, I can just port this Spring Boot Java application to Lambda and it'll be okay. Maybe that's what you need to do. Maybe you have a legacy use case or application where you have to do that for. But I might reconsider doing that and maybe writing it in a different language or dropping the Spring Boot framework altogether. I think that's what we ended up doing, is just dropping Spring Boot.
Mm-hmm. Yeah, that makes sense. Yeah, and so I'd like to ask another question too. Like, are there situations where you think it would be beneficial to use Lambda in conjunction with Fargate?
Yeah, I think there's a lot of good scenarios for that. One of the common things I've seen is using Lambda to initiate or invoke or start up the Fargate tasks. Maybe you have a process where you need to check something on a timer. So you have a Lambda function and it's invoked every however often, minute, hour, day. And you need to check a condition. And when that condition is met, you need to do some larger work. So you can use that Lambda to perform that really quick check that needs to happen, and then have it invoke start up those tasks that run and perform that long period of work. Maybe it's something like we have data. We do a lot of message transporting, like I was saying before, and you need to you need to send out messages. So maybe you need to see if there's messages available to send out. And if there are, you need to start up a task to send out all of those messages. And then once they're all sent outbound, you can shut the task down. So it's almost like a launcher. You could use a Lambda to invoke those Fargate tasks.
Yeah, and just offload the longer running workloads, the asynchronous workloads off on the Fargate. Yeah, that reminds me of a project that I had been working on involving machine learning as well. And with machine learning tasks like training an AI model, running inferences like batch inferences, sometimes these can be very compute intensive and they may need GPUs rather than just regular CPUs. And so I've actually used this before in conjunction, Lambda and Fargate, where Lambda would handle the requests coming in as like the back end of an API and then trigger batch inference jobs using ECS and Fargate on the back end, like asynchronously. So yeah, I think that there's your comment just reminded me of that there's definitely something to be said for using them in tandem where it's appropriate.
That's a good point. And I think with Fargate, you do have a little more control over how your environment is configured. Environment in terms of your operating system and runtime. I believe the Lambda functions are going to use AWS Linux to be the operating system, but with like Fargate, you can specify your own OS that's installed on the container. And I think you have a bit more flexibility in terms of how much CPU it has, how much memory it has, how much storage it has. You can control those with Lambda too, but I think you can go even farther with Fargate. I was looking this up just before the podcast here, and Lambda has come quite a ways. I think you can run 10 gigabytes of memory on a Lambda container now, which was pretty good. But Fargate, you can go even farther. So if you really have those like CPU intensive workloads, memory intensive workloads, I think you have a lot more configurability with Fargate in terms of the performance.
Yeah, absolutely. So I'd also like to get your thoughts here while we have the time. What are your thoughts on the differences in the pricing model between Lambda and Fargate? Like, is there one that's considered low, like more cost effective than the other? Or I think we might have lost Preston.
The use case you have, I think both are cost effective. But I really think if you're not using your time wisely in AWS Fargate, you're wasting money, because you're not doing any kind of computation. You're just having a service sitting there not being used. That said, I don't think you want to use Fargate for small, frequent jobs. That's where Lambda shines. It does cost more money to invoke Fargate. So that's why it seems like the larger but smaller quantity of workloads is good for Fargate, whereas the smaller jobs but much larger quantity are great for Lambda. So that's the choice to make. When are you going to be invoking too many containers that Lambda really should be used versus using Fargate? I think that's where the cost factor comes in and the decision you need to make.
Right, absolutely. Yeah. And almost a counterpoint to that. I had been talking with Adam, who hosts the podcast regularly as well. And he had found a blog that was an interesting, somebody sharing their experience with Lambda and Fargate. And they said that they had reduced their compute costs by 90% by switching away from Lambda to Fargate. And I was thinking, like, how the heck did that happen? So, in reading it, what they had discovered was when switching they were initially having they were using Lambda as a web API, like a backing web server for like a RESTful API, and they had that with API Gateway in front of it. And they realized that they weren't using all of the features that API Gateway provides, and they could really just get away with switching to something like using ALBs with Fargate containers rather than Lambda functions. And even though the costs they incurred by Fargate were twice as much as what they incurred from Lambda, the costs of API Gateway were so high that switching away from that dramatically reduced the overall cost, which was kind of funny. I thought, like, well, that's kind of like a hidden. There's like when looking at it holistically, you can find almost like these hidden costs, because a lot of times for Lambda to be useful, you have to use it in conjunction with these other services. But yeah, I just thought that was kind of an interesting thing that I wanted to share.
It is interesting, and with AWS services, it's really kind of like putting a puzzle together when you make an architecture. You just have all these services to work with, and you kind of move them around like, well, how can I be cost effective and get my work done? It's really interesting. And, like you said, there are multiple ways to do the same work. And obviously cost is a major factor, but also, is this, am I using my services effectively? And there's so many features with these services that you might not even know there's a feature available that would really, change your decision. So, and these things change, constantly. It's amazing how fast they're putting out new features on all the services. So it's critical to stay up to speed on what new features are coming out with Lambda. Just like I was talking about that Snap Start thing, which is very new. They get these things out and they're available to use right away. I mean, this is a quick thing too, but one of the cool things with Lambda is that and other services too is that AWS has a free tier to use. And I know it sounds like you're doing a PSA for AWS here and promoting all their services, but they do have a free tier, which Lambda, I think you can get a lot of invocations for free with Lambda. And so that's also a factor into building your architectures too, because maybe you'll actually fit into the free tier up for Lambda for your job. Depending on what your company does or what your business does. But Fargate doesn't have a free tier. You just pay as much as you use, but Lambda starts off with a free tier. And so you get a bit of, runtime before you start paying with Lambda. And of course, personally, if you have a personal, account, it's great to use and practice and not pay money for Lambda. That's a cool thing to do. But it's something that you have to, keep up to date on to see what's available. And, your architecture might not be right the first time and you need to, re-architect it and try it a different way. It's certainly happened with us many times.
Right. Yeah. Yeah. I think for the free tier for Lambda, it's like you get the first 1 million requests for free, something like that, which is, I mean, depending on how, what the scale of your application is, that could be a huge benefit. But yeah, with something that hits Lambdas quite a lot with a lot of concurrency, that might only go so far, but it is definitely a help.
I do want to just real quick go back to something you talked about with API Gateway too. That's if you're using API Gateway and, you need requests to come in from the outside. Lambda can be invoked directly from, another Lambda or even an ECS task. I think we talked about how you could, invoke an ECS task from a Lambda to kick off some jobs. But the same is true the other way too. If you have a Fargate task that's running, you can invoke Lambda functions from that. Maybe you need a small piece of work that's done during your long-running, Fargate process. It's just as possible that you have architectures working the other way too, or those services to work together.
Yeah, and that also helps to avoid any kind of like networking costs from data being transferred between VPCs or something like that. But yeah, I think that's a great point. Um, so it looks like we are coming up on time. I just wanted to get any remaining thoughts that you had, Preston, before we conclude today.
I think they're both great services, and we leverage both of them extensively. Fargate, we didn't talk about it that much. That you can use AWS has their Elastic Container Service (ECS) you can run in Fargate, as well as Kubernetes. So there is a little bit of flexibility there. I think these are core services that should be leveraged probably in a lot of different architectures, and it's exciting to see the changes that happen because they're very frequent and they're always adding new things. So certainly a great tool in our arsenal.
Yeah, absolutely. All right, I think that's pretty much all the time we have for today, but I want to take this opportunity to thank all of our listeners for tuning in to today's episode.
Sorry to interrupt, Jason. I think David actually had a question. So yeah, David, you request to speak. What's on your mind?
Well, I don't want to take up too much extra time from everybody, but I haven't used serverless yet. And what happens when you're offline? I'm on a plane and I'm trying to run my local host. Is there a package or some sort of container that AWS or GCP allows you to run these serverless functions offline?
That's kind of a tricky one. So I know that if you're working offline, if you have Docker installed locally and you wanted to test, like if you were traveling or didn't have access to internet at the moment, you could potentially run the containers locally, and then you could just as easily run them on ECS when you do have internet again. Additionally, too, with Lambdas, they are very much geared towards being run in the cloud, but we have been able to write Lambdas in such a way that they could be run just locally as, for example, like a Python script. That's one of the runtimes that Lambda supports. So we could run the Lambda locally to be able to test it, continue doing local development as necessary, and then push it out to AWS when we're ready to go ahead and test the code, like in its cohesive environment with everything else.
Yeah, because that's what I don't like about it, is that you're almost like putting your source code on their end. Like I don't have it in my local editor on my local file system, attached to a Docker container, like a traditional script.
I'll agree with you that it's local development is certainly more of a challenge with serverless and cloud services. You're not going to be able to use all of the services on your local environment. You're not going to be able to use their API gateway, their SQS, any kind of compute runtime like this Lambda or Fargate. Yeah, we're going to have to run on Docker on your local machine. Or they also have something called AWS SAM, which is a serverless application model, which kind of mimics Lambda. It's difficult to set up, and like Jason was saying, probably the easiest thing is to, have unit tests that test your code locally, and then run your core functionality. I think there's still some work to do to really get a local environment that mocks exactly what the web services offer when things are hosted there. Good point.
How do you manage with other people modifying the same files for these cloud functions at the same time? Is it connected to Git? And, if people are changing it at the same time, trying to do development work, it just seems kind of different.
It's true. We have it structured so we have, right, let's say you have one environment in the cloud. There's one instance of that code, so only one developer can push their code there at a time and run that code. So there's got to be some teamwork in terms of deployments that are going on to the environments. And I guess that's why it makes it all that much more important to have unit tests locally to run your code before you're ready to deploy it. But yeah, we have to have coordination to deploy things. We do have, two environments. So we have like a development environment for developers to push their code to. And then once we have that, we've done our testing, we have a test environment where we can push it so our QA team can develop to test the code there. So we do have kind of two development style environments, but again, it's one developer pushing their code there at a time.
Okay, at least I understand that. And my final question, we'll try to wrap it up real quick, was, these different runtimes, whatever language you have, there's frameworks like Django, whatever, and all of them kind of take a request differently in their objects or how they receive the request response flow. Do you run a full framework in these, or is it a simple function that you have to receive like the request and output a response?
Good question.
That's what I'm.
Yeah, good question. So you don't have to run a framework with your code, but you can.
Okay.
So if you're using API Gateway, which is very common for receiving like an HTTP request, what API Gateway does is it receives the request and it generates, let's say, a JSON representation of that request, which it passes that JSON to the Lambda. So you have this payload, this JSON payload, and without any framework, you can, use the fields in that JSON payload, which, has everything in it.
So you can get all the headers. You'll get all the headers and the JSON payload and stuff like that, right?
Right. Depending on, like I said, you can use a framework like Django, or we use Flask in Python for some of our applications. And they have libraries that will transform that JSON payload that API Gateway produces. It'll transform that payload into something that the framework can understand, like into the format that Flask or Django can understand. And so then you can use those Flask or Django libraries in your code.
Okay, and people typically do like database connections and session management with who the user is in these, serverless functions.
We actually didn't get into that too much today, but yes, the Lambdas can connect to database. That was actually another challenge that I had listed out, is connection pooling. And, if you have all these Lambdas that are running, let's say 1,000 or even more, maybe your database isn't equipped to handle 1,000 database connections at a time.
Yeah.
And there are solutions to that with Lambda. There's a database proxy service that acts as a connection pool for connections from Lambda. So there are techniques to managing those database connections, because you're right, it can be an issue when you scale out that far.
Okay, great talk. Thanks for all your help. You answered all my questions.
Yeah, thank you. We really appreciate you participating and asking the good questions, because it helps to make this definitely more insightful conversation. Great. So I guess we could probably wrap up there. Again, I'd like to take the opportunity to thank everybody for listening in on today's episode of Lunch with Tech Leaders. Hopefully everybody found the conversation useful and insightful. And we'd love to have you join us again for the next episode. And our topic for that one is going to be AI, is regulation necessary? As always, the episode will feature expert guests and interactive conversations, so be sure to tune in. Thanks, everybody, and have a great week.